All right, so our first presentation of today is a talk given by Kelsey, but being presented based by Kelsey Young as well as Noah Petro. And this is the Artemis II overview.
Julie, you're stuck with me for the first talk. So although, like I just said, we're not focusing on a specific mission today, we did want to provide an overview of Artemis II as it's the next mission up on deck. We're really excited about it. Science is heavily integrated throughout the mission. I'll talk about the ways in which we are. So we did want to dive a little deeper on this mission just because there's been some more advanced planning and it's next up. So I will not dwell on this slide because Mark Blanton is speaking after me and is going to do a far better job of overviewing the mission, but I'll draw your attention to kind of a couple of the critical phases during this mission. Post-launch, the crew will spend a little bit of time slinging around the Earth to prepare for translunar injection. They will have approximately 4 days in transit from the Earth to the Moon, where there'll be some science tasks, trajectory reviews, geography reviews, and opportunistic imaging. They'll then complete the lunar flyby, where we'll have opportunity for the crew to make observations and take images, which I'll talk a little bit more about in a minute. And then they'll, of course, have the transit back to Earth, where again, they'll have some time to debrief what they experienced during the flyby and again, take some opportunistic images. So Mark Blanton, after me, will give a much better look at this mission profile, but here is an overview for you. So what can we, the lunar science community, expect from this mission? Here is our crew. We've already had some time with them. From a training perspective, they are ready and excited to go, and they're excited about the science connections, specifically the lunar science connections for the mission. We can expect crew and vehicle imagery from the lunar far side. You'll hear me say several times, we don't know the exact trajectory and illumination conditions because we don't know, of course, the exact launch date, but we can expect imagery during the flyby. We've already made some really great inroads with the Flight Operations Directorate in terms of science integration into operations, and we're excited to implement those with the first crewed mission for Artemis. We also look forward to learning a lot of lessons for Artemis III and all the missions that follow it. We'll learn a lot of important things about how to integrate lunar science into Artemis operations. And for example, we'll be able to test things like integrating the science evaluation room, which is the science back room for Artemis. Now, here are a few notional looks at what the far side could look like to the Artemis II crew. Again, we do not know the final trajectory, so this is these are just notional images of what they might see based on exact launch date and associated illumination conditions. Mark, who's speaking after me, will do a far better job of showing you the realities of this mission, but here is just to give you an idea. We don't know what illumination to expect, but we do know that the crew will be given the opportunity to observe and photograph the far side no matter what the conditions are at the time. Okay, so what lunar science can we hope to accomplish? We will rely on crew observations and crew and vehicle images as the basis of our science. We will not have additional lunar science crew handheld payloads on board this mission. Depending on the timing of the flyby, we will come up with a mission and imaging and targeting plan that reflect that reality, building on, of course, the fact that 3/4 of the crew has experience observing another planetary body and imaging that body from ISS. Based on the exact illumination conditions that are present when we launch, we will have the opportunity to observe the far side for color variations, albedo characteristics, and image targets of opportunity, although we are putting together an image plan for all possible launch dates that we'll draw from once we understand the exact launch date and illumination. This will allow us to get the initial human observations, human eyes, and human handheld imaging of far side features. Like I said, we'll develop a list that is agnostic of launch date, but it will afford us an exciting opportunity for far side imaging. We will also have a few other payloads on board the mission, things like radiation monitors, as well as a payload from the Biological and Physical Sciences Division. We will have an LSSW focused specifically on BPS coming up in early 2024. So really looking forward to that conversation with that community. We are integrated, lunar science is integrated across Artemis II in the plan, train, and fly mission phases of Artemis. So diving a little deeper into that. In the plan phase, which we are firmly in right now, it is a very active and exciting time. We're working on all of the different ways that we can get science objectives, lunar science, accomplished with crewed activities during all phases of the mission. Specifically during the lunar pass, we're of course extremely excited for that because it will afford the far side views. By way of a few recent updates, and in fact, since we last spoke about this topic at the league meeting, we just recently completed some acoustics testing of multiple configurations of a microphone and headset and the crew tablet that the crew will have on board, which is the tool that they will use to record their verbal observations during the lunar flyby. So a couple of us completed that work at the Orion Acoustics Lab at the Johnson Space Center. We are actively planning image targets for the crew, and we're working with the amazing team who has supported not only Artemis I, but the International Space Station in terms of imagery analysis and real-time support. You'll hear from several of them later today on developing that target plan and implementing it with the crew. And we're also solidifying our lunar and planetary science objectives for the mission that image plan will feed. From a training perspective, you've heard us talk about this at League before, but we have delivered lunar fundamentals training to the Artemis II crew back in May. We also delivered field training to half of the crew at the Mistastin Impact Structure in Canada back in September. And additional training is expected for the entire crew on science objectives for what they'll be doing during the mission, and things like how to actually implement the targeting and image plan that we'll send up to them. We'll also, of course, complete training for the flight control team that will support this mission. We will have a science team and a science officer in the flight control team supporting this mission. And of course, we'll be delivering training to all of those personnel in the months leading up to the mission. In fact, we anticipate that training to start in January of 2024. During the fly phase, we will be imaging the moon and imaging the Earth as it's visible to us with Orion spacecraft orientation. So we are planning a series of science activities that, again, include imaging and observations during the lunar pass and opportunistic imaging during the transit phases, both to and from the moon. Science will be integrated real time into the flight control team. The science officer will be the senior flight controller that represents the lunar science objectives during the mission. They will be supported by a populated science evaluation room that is being constructed right now in FY24 and will be operational for Artemis II for its first mission that it will support. We're actively developing our operations products right now. That includes a review of lunar geography, which is currently being reviewed by the crew. And we're working on developing our image and targeting plan, again, in conjunction with our wonderful image analysis colleagues. We're also working on applying ISS imaging lessons learned to Artemis and learning from our colleagues who have supported ISS for so long. You'll hear from several of them later today. And again, we will have a biological and physical sciences payload on board. I believe a selection was recently made, and so hopefully we'll hear publicly from BPS soon about that exciting payload on Artemis II. Hopefully I don't need to convince this audience, if you showed up today, on the importance of Artemis II and preparing for the future, but it is a really excellent opportunity to integrate lunar science into active human spaceflight mission planning and objectives prioritization. This is something that for lunar science has not happened in quite a long time, and we're learning a lot about the current environment and how to best get our lunar science objectives prioritized within the mission profile. We're also going to learn a lot during this mission about understanding how to acquire imagery and downlink it to a place where the SIR and the science team can use it real time. This will be especially important as we move into future missions where we have a lot more time either on a lunar surface or in lunar orbit. So understanding that architecture will be critical, and we'll learn a lot from Artemis II. We'll also integrate discovery-based real-time lunar science into executing the mission and to the structure of the flight control team. That is going to be really critical, speaking as the Artemis Science Flight Operations Lead, to learn how to do this as we move forward in the Artemis mission profiles. And of course, it's just a proving ground for future orbital mission phases as well. We'll have this flyby opportunity during Artemis II, and we look forward to implementing lessons learned when we have more time in lunar orbit on future missions. So to wrap it up, of course, for the first time since 1972, we are sending humans to the moon. Work is heavily underway to integrate lunar science across Artemis II. The Artemis II crew will be focusing on lunar observations and handheld photography during the lunar pass and opportunistically at other points during the mission. We're looking forward to hearing from you today on anything you want to see accomplished for phases such as this. The Artemis II crew has already received lunar science training. We expect more time with them before they launch. And we're looking forward to learning a lot from Artemis 2 as we pave the way to the future, and looking forward to capturing your inputs about that future here today. So I'll end there and kick it back to Julie to introduce our next speaker.